Hello. In this video, we want to look at this question. Suppose the cost in dollars of manufacturing X 100 small motors is given by C of X is equal to 3x squared plus 120 all over 2x plus 1. And there's this extra condition here that 10 is less than or equal to x is less than or equal to 20. In other words, x has to be between 10 and 200. My apologies. Now, A, find the average cost per 100 motors. B, find the marginal average cost. C, as we shall see in the next chapter, average cost is generally minimized when the marginal average cost is 0. Find the level of production that minimizes average cost. Okay, so we're going to work with A here. A says find the average cost per 100 motors. Now, don't let the per 100 motors confuse you, because up here, X is in 100 motors. So that just means that we're dividing C of X by X. That's all it is, since X is in 100 motors. So average cost, by definition, C bar of X is C of X divided by X. But let me rewrite it. I want to bring the C of X to the right-hand side. And so we have over X there times C of X. But notice what's happening here. If I brought the C of X out of the numerator, there is something left in the numerator, but it's just the number 1. And so what we need to do is we want to go ahead and put this right here. Now, the reason that I'm doing this instead of putting it all over X is because we'd have a complex fraction, and it's just easier to see this way. So replace the C of X with what it is. So we have 1 over X times 3x squared plus 120 all over 2x plus 1. And now notice what we can do. We can distribute the x in the denominator and the 1 in the numerator if you want to, but it doesn't really change anything. So that means that your average cost, C bar of x, is equal to 3x squared plus 120 all over 2x squared plus x. And this is your average cost. Excellent. That's A. Average cost per 100 motors. B, find the marginal average cost. Marginal average cost just means the derivative of the average cost. So on B, we want to find C bar prime of X. So we're going to take our answer from before and just find the derivative. That would be the bottom, which is 2x squared plus x, times the derivative of the top, which is 6x, 6x, not 6x squared, just 6x, minus the top, 3x squared, plus 120, times the derivative of the bottom, which would be 4x plus 1. And then all over bottom, 2x squared minus x squared. Excellent. And at this point, you just multiply everything out. Multiply out 2x squared plus x times 6x, and 3x squared plus 120 times 4x plus 1. So this is going to give you 12x cubed plus 6x squared, and then minus, over here, I'm going to go ahead and FOIL this out, parentheses, 12x cubed plus 3x squared plus 480x plus 120. Close parentheses, all over the bottom, which is 2x squared minus x all squared. Awesome. Now notice that in the numerator we can distribute and then combine like terms. So this is going to give us 12x cubed plus 6x squared minus 12x cubed minus 3x squared minus 480x minus 120. All over 2x squared minus x squared. Awesome. Now in the numerator, combining like terms, 12x cubed and negative 12x cubed cancel each other. It's fantastic. 6x squared negative 3x squared becomes positive 3x squared. Then we have 480x, or negative 480x, and minus 120 at that point. All over 2x squared minus x squared. Now this should be c bar prime of x, and I'm just curious if this will simplify it all. Now notice that the denominator is x times 2x minus 1 all squared, right? And I'm just going to show you the reason that I'm curious about this is the following. We have, in the numerator, there's a common factor of 3. So if I factor out the 3, we get 3 times x squared minus, now 3 goes into 480 how many times? Well, 3 goes into 4 once, 1 remainder, 18, 6, there you go. So negative 160x minus 120, or 3 goes into 120 how many times? Well, that would be 40. Does anything multiply to 40 and have a difference of 160? Well, no, it doesn't. And so as a result, nothing will cancel. Or this can't be factored. Come on now. The denominator, if I factored out the x, I would have to factor out the x squared technically. And what you'd be left over with is the 2x minus 1 all squared. And since this cannot be factored, nothing will cancel in the denominator, which means that this is as simplified as it will get. Alrighty, good deal. So that is the marginal average cost. Now, let's think about what that means physically. Marginal cost is the cost to produce just one more. Average cost is, well, just add up all the cost and divide by the number that you have, and just tells you the average of everything that you had. Now, that tells me that the marginal average cost would be, what would the change in the average cost be if we did one more next time? And that's really what the marginal average cost is telling us. Alrighty. Now for C, as we'll see in the next chapter, the average cost is generally minimized when the marginal average cost is 0. So find the level of production that minimizes average cost. In other words, take this answer here and set it equal to 0 and solve. So in other words, 0 is equal to 3x squared minus 480x minus 120 all over 2x squared minus x squared. And the great thing about this is that since this is a rational function, I can multiply both sides by the denominator, but notice that 0 times anything is 0, which means that that goes away. In other words, the only thing we need to know here is when is the numerator equal to 0? And I already showed that you can divide everything there by 3, so let's go ahead and do that. So it gives me 0 is equal to, because I'm dividing 0 by 3 as well, x squared minus 160x minus 40. But that can't be factored. And since that can't be factored, it has to be solved using the quadratic formula. So using the quadratic formula, here I'm going to let a be 1, so understood 1. B would be negative 160, and C would be negative 40. So it means that b squared minus 4ac would equal what? Well, that would be negative 160 squared minus 4 times 1 times negative 40. And this is where I get my calculator out because I do not know what is 160 squared. Well, that's 25,600. And then I'm going to add on that 160 there. There we go. So it's 25,600 plus 160. It's plus because there's a negative and a negative. So 25,600 plus 160, add those together, will give us 25,760. And if you want to check to make sure that this is not a perfect square, just type it in, square root of that gives you 160.4992212, and so on and so forth. So basically, yeah, it's not a perfect square, which means that this could not be factored. It's another way of checking. But now that we know that, we can go ahead and do the quadratic formula. X equals negative b plus or minus a square root of b squared minus 4ac all over 2a. Awesome. So let's plug everything in. Negative b means positive 160 plus or minus the square root of 25,760 all over 2 times 1, which is 2. Alrighty. Now, what I did when I typed this in is I actually already did square root of 25,760. So approximately, this is not an exact value, 160 plus or minus 160.4992212 all over 2. Awesome. And at this point, just type it in. 160 minus all that, all over 2, and then 160 plus all that over 2. So let me do this. So what I get whenever I do the minus, that's going to give me negative 0.2496 blah, 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 comma. And let's do this again. Plus the 160 over 2. Gives me 160.2496106. Awesome. So we're going to actually reject this. The reason why is because x is representing the number of 100 blah, whatever this was. 100 small motors. And there's no such thing as a negative amount of small motors, so we can only use the positive. So this tells me up here that because the average cost is generally minimized when the marginal average cost is 0, since the marginal average cost is 0 at 160.249 blah, 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 then x would be, in 100 small motors, 160.2496106. So x is 160.2496106. Now the reason that I went ahead and wrote everything out is because the units here are 100 small motors. Now notice the units are 100, so anytime you have units, it's multiplication. So times that 100. So this times 100 means I need to take this decimal and move it right 2 places. And I'm going to cut it off because there's no such thing as a part of a motor. Well, I guess there is technically a part of a motor, but we're going to go ahead and round it anyway. X is equal to 16025. So 16,025 small motors will minimize the cost. Alrighty. Well, there you go. Here is everything we did here, or at least, yeah, everything we wrote down here. Alrighty. I think I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.